of 6 books. He discovered and named numerous new species of mushrooms and is the founder and owner of a brand of fungi perfecti. Paul's philosophy is that mycodiversity is biosecurity. He sees the ancient old-growth forests of the Pacific Northwest as a resource of incalculable value, especially in terms of its fungal genome. A dedicated hiker and explorer, his passion is to preserve and protect as many ancestral strains of mushrooms as possible from these pristine woodlands. He's received numerous awards, including Invention Ambassador for the American Association for the Advancement of Science, the National Mycologist Award from the North American Mycological Association, Gordon and Tina Wasson Award from the Mycological Society of America, and lastly, and for some most significantly, in the Star Trek Discovery series by CBS, the science officer is portrayed by an astromycologist, Commander Paul Stamets. Paul is a consultant on Star Trek, and his ideas on mycelium and warping hyperspace has set the foundation for the series. Now please join me in welcoming Paul to the stage.
Well, I'm honored to be here. There's many friends in the audience and soon to be more friends. This is an immersion talk. We're going to do a deep dive into the MycoVerse. The end of this talk is going to have some profound implications that I hope will inspire you, give you hope, set a foundation for future generations, be able to change our future on its current path to something that's far more sustainable. Now, before I begin, I want to just have a show of hands, and this is a legally okay question to ask. How many people here have not ingested psilocybin mushrooms? Those of us who are in psilocybin experience I want us to welcome you to our tribe. So, I'd like to mention my hat. I think it makes me look quite handsome, especially since I'm balding. And psilocybe mushrooms are known as the bald-headed mushrooms. That's what psilocybe means. This hat is actually made from this mushroom called amadou. Its Latin name is Fomes fomentarius. It's a birch polypore. It's quite hard, grows on birch trees. And our ancestors discovered that this allowed for the portability of fire. You can hollow this mushroom out, put embers of fire inside, and literally carry it for days. There's no doubt that we all came from Africa. We are Africans genetically. We moved north into Europe, we discovered something new called winter. Oops. And this allowed our clan to survive. Without fire in the winter, we would perish. And you hollow this mushroom out, put embers of fire inside, and it can be kept for a number of days. Moreover, when you soak this mushroom in ash water, and it delaminates into a fabric, and this is the fabric, and some ladies in Transylvania have made this hat. There's only a few families that have kept this thread of knowledge alive. How many threads in the fabric of our history have we lost, have been frayed and broken due to disease, religious persecution, extinction, climate change, religion? So this mushroom also revolutionized warfare because it allowed flint spark guns to ignite the gunpowder. The Chinese invented gunpowder, but the Europeans invented the rifle. Moreover, fly fishermen would use it for drying their flies. Beekeepers use this for smoking their beehives for hundreds of years. This mushroom also is the first known mushroom to have an antiviral substance against the tobacco mosaic virus. So this is one of the species that I think have been pivotal in helping humans survive over the millennia. Now, I'll be talking about several other mushrooms too. I'll be talking about reishi. Many of you know of this mushroom, the mushroom of longevity. I'll be talking about the red-belted polypore, Fomitopsis panicula. I'll also be talking about chaga. These are all polypore mushrooms. And chaga is sort of a sclerotium, it's a sterile form that forms also on birch and beech trees. These species all will be covered tonight, and they have profound implications for our survival in these challenging times. But moreover, there is another friend that I'd like to show you. And this is one of the rarest of mushrooms, growing exclusively in the old-growth forest. This is Agarikon, Fomitopsis officinalis. First described by Dioscorides as elixirium ad longum vitam, the elixir of long life, in the first Materia Medica in 65 AD. This mushroom grows exclusively in the old-growth forest of the Pacific Northwest, Northern California, Oregon, Washington, British Columbia, and it now exists only a few sky islands in Europe. This mushroom is so important for, in ancient times, thought to be a treatment against consumption, later to be known as tuberculosis. But we fortunately have some old-growth forests left today, and I consider these as genetic libraries, not only of our ancestors, but so important for our descendants as we move into the future. Brace for impact. As we voyage into the MycoVerse, mushrooms, mycelium, and the mycology of consciousness. Thank you, CIIS, for sponsoring this talk. You know, there's a great program to graduate future psychonauts into therapists. And this is something that I think a lot of us can benefit from into the future. But I'm a deadhead. What a long, strange trip has been, said Jerry. And indeed, it is time to enter into the paradigm shift. So, I'm going to quickly go through a lot of slides here, and these slides are going to weave a story of improbable conclusions. But once you understand where I come from, it makes sense. But just to tell you the conclusion of my talk now would be premature. Mushrooms form from the mycelium. The mycelium forms little primordia babies. The mushrooms mature, gills, spores are formed, spores are released, two spores come together, they mate, and the cycle continues. The mushrooms, not these polypores, these are perennial polypores, some of these, but most mushrooms, 99% of them, are highly perishable. They attract insects, mycovores, people, animals, and their scent, fragrances, and their deliciousness means they're highly perishable. But the mycelium navigates over months, years. The mycelium is resident in ecosystems throughout the planet. The mycelium of Psilocybin cubensis growing over 5 days. Many of you may not know the largest organism in the world is the mycelial mat in eastern Oregon. 2,200 acres in size, 1,665 football fields, and yet is only one cell wall thick. How is that possible? The mycelium forms a fabric, an intercellular network of cells that are lattice work. And under the correct conditions, a drop, introduction of water, we all know that. And with water, we have reduction in temperature through evaporation, the second signal. The third is the mycelium comes up to the ground, exhales carbon dioxide, inhales oxygen. It breathes. And then the fourth one is exposure to light. 99% plus of all mushrooms require light. They're phototropic. They need light in order for the mushrooms to form. Those four stimuli signal the mycelial mat to reproduce. The mycelium then forms primordia. The primordia then are explosive in their rate of growth, going from seemingly something invisible to full maturity in as little as 5 days. And the mycelium then aggregates to form a primordium. And now I'm going to start seeding you with little thoughts here, little factoids. These are important for you to understand the big picture of what I'm trying to explain. Blue light stimulates mycelium to form primordia at 320 to 400 nanometers. The mycelium then produces the mushroom. It attracts insects. It attracts us. The mushrooms quickly are perishable. The mushrooms then rot with bacteria. Spores then germinate. And coming back to these mushrooms a few days later, the mycelium goes subsurfacely. In a single inch of soil, there can be up to 8 miles of these cells. The mycelium digests its nutrients externally. These are externalized stomachs. We diverged from fungi 650 million years ago. Fungi went the underground route, digesting its nutrients externally. We went and encapsulated nutrients in a cellular sac, basically a stomach. and that is the split between fungi and animalia. There's a new superkingdom called a Psilocybin. At a time when fungi and animals are joined together, that was the unified kingdom of us both. It is now just recently reported in science that there's more than 1,000 species of bacteria that exist in a single gram of soil, all enmeshed within the cellular matrix of miles of mycelium. The mycelium sets up the microbiomes of the bacterial populations that then control and help evolve the plant and animal communities that give rise to the canopies of trees that create debris fields that could feed the mycelium. These are deterministic in their evolutionary paths to preserve biodiversity and mycodiversity for the benefit of the commons. The mycelium forms a beautiful architecture. There's no site-specific place where the mycelium can be damaged. It's a network-based organism. This is the mycelium surfacing, exhaling carbon dioxide, inhaling oxygen. These are externalized not only stomachs, but lungs. And moreover, they have an innate intelligence about them. Through epigenesis, this is some movies by my friend Patrick Hickey. These are bundles of nuclei, sometimes hundreds of nuclei streaming through the networks. And the extent of my hands outstretched right now, there are literally trillions of end tips. And they're multi-nucleate. And so the end tips, if they encounter a new insect, a new toxin, a new potential source of food, if they code for a new enzyme, a new acid, a new way of breaking down that foreign substance, what happens? Then the genetic information then back channels into the mother map. It becomes resident within the inherent knowledge of the mycelium, and it can utilize that in the future for breaking down a potential food source. The mycelium surges because it has food. I believe these networks are self-evolving, and that nature represents building upon prior evolutionary successes. And so the mycelium, it has the same common structure that of neurons. Looking at the organization of the computer internet, which I believe was invented based on the prior evolutionary successes of networks at a time critical that we needed to invent new ways of communication and sharing information at a point where our ecosystems and our species are facing huge calamities. So looking now back in time, the Big Bang occurs 13.8 billion years ago. Matter then suddenly appears. The cosmos expand. And then looking at the broadest view of the universe, this is 1 parsec, 3.26 light years, 19 trillion miles. And backing off now the greatest expanse of the universe that can be conceptualized, it also conforms to the same architecture shared by that of the mycelium. Looking at the organization of dark matter also conforms to string theory and these network-like structures. Each of those ellipses are galaxies, 180,000 galaxies in this deep field view from the Hubble telescope. And so 13.8 billion years ago was the Big Bang. Then 4.6 billion years ago, the Earth began to form. Soon after the Earth began to form, the planet Theia slammed into the proto-Earth to form the Moon. And so after 4.5 billion years ago, when the Earth formed, the first indications of life, monocellular organisms, have been found in the cellular in the fossil record of single-celled bacteria. I believe matter begets life. Life becomes single cells. Single cells divide, replicate, strings form, they fork, membranes form, guilds of membranes form. The microbiomes are established based on the lattice work of these intercellular networks. And so, this is just recently published in 2017, the oldest representation of an intercellular organism found so far has been in South Africa in lava. It is that of mycelium. Now this is so important because we diverged from mycelium only 600 million years ago, 1.8 billion years later. Animals came from fungi. You came from fungi. Fungi are our ancestors. We are all representatives of these fungal bodies. We go advancing in time to 420 million years ago. A giant fossil has been found in the record in 1856. Very hard to understand what it was until Dr. Kevin Boyce, Francis Hoover determined that this giant fossil was named then Prototaxides. It was only in the past 10 years that Kevin Boyce determined that Prototaxides was indeed a giant fungus. In fact, it was the tallest organism on land. Over approximately 30 meters in height, 10 meters in height, about 35 feet in height. It towered over the landscape above any other organism on the planet. Before vascular plants had formed, there were ferns. These towering structures dotted the landscapes of Earth, attracting lightning strikes, electromagnetic fields, a perfect place for epigenesis. The microbiomes of bacteria would be growing, they're electrified. These dominated for about 40 to 60 million years. Then we go forward into time. There was a huge catastrophic event, a giant extinction event. Putatively, it is thought to be an asteroid impact. And when the asteroid impacted the Earth, it created earthquakes, volcanoes exploded, methane hydrate burst into the atmosphere, and more than 90% of the species on this planet became extinct. This is the great PT boundary, the Permian-Triassic extinction event. And it's quite clearly seen in the fossil record. 250 million years ago, after that debris was jettisoned into the sky, sunlight was cut off, plants and animals died, and fungi inherited the earth. In fact, we know what this fungus is. It's been given a name, Reduvius sporonites. It gobbled up the forest. It's the most predominant fungus in the fossil record. And then we advanced to Pangea, and then to Gondwanaland. The continents then began to separate. And then the landscape of the planet became more recognizable as we see it today. And we move forward, and now another fungus has been discovered just recently in Brazil, and 110 million years ago. And mushrooms had their form. These are ancient elders that are resident within the ecosystem. It's so ironic that humans are so blind to the members of the ecosystem that are so essential for our survival. Then we march forward into 65 million years ago. We have another great extinction event. We all know about this. An asteroid impact comes and lands just above the Yucatan. We have another huge concussion, enormous amounts of debris field jettisoned into the atmosphere, light is cut off. Plants and animals, the dinosaurs became extinct, and fungi re-inherited the earth. There's a recurring theme here, folks. When we face extinction events like we are today, those organisms that pair with fungi survive. And here we see the earth. And then animals diverged from the fungal tree of life 600 million years ago. And so we evolved into present day. But prior to that, this is really interesting. I looked this up and I was astonished to find there are 22 primates that consume fungi, mushrooms. 23 counting humans. And these primates know the differences between edible and poisonous ones. This is the Golgi monkey that consumes more than 12 times its body weight in Brazil. So, and it consumes a mushroom called Ascopolyporus. Well, this ancient history that we can see today of primates consuming mushrooms speaks backwards in time, in my mind, to something more fundamental. And so I present to you something that I think is an astonishing mystery that may be solved when we look at the use of mushrooms in the historic record. 2 million years ago, our brains suddenly doubled to tripled in size. They began, now some people say 200,000 years ago, some people say 2 million. I'm giving you a range, 2 million to 200,000. But this is unprecedented, how the brain was suddenly enlarged so quickly. So what does this mean? It was associated also with climate change And so there is a theory called the stoned ape theory. I don't call it a theory, I call it a hypothesis. But let me walk it through with you. Our ancestors were tree dwellers. As the savannas increased due to climate change, we were forced out of the trees and across the savannas. You were hunting animals, ungulates. You come across scat, poop, dung. In the tropics, the most common mushroom is Psilocybin cubensis. It's a large mushroom. Our proto-ancestors consumed these mushrooms. They were hungry. They shared it with their friends and their family. Suddenly, synesthesia. Oh my gosh. What's happening? Neurogenesis. Neurons being stimulated into reproduction. Consciousness is raised. We didn't have TV. We had mushrooms. The brain suddenly surged in size. The most common mushrooms I mentioned were these psilocybes, Psilocybin cubensis in particular, Pinellus cyanescens or Copelandia cyanescens. So this was first proposed by Terence and Dennis McKenna as a stone ape hypothesis. Now, factually, they call it the stone ape theory. I disagree with them. It is not a theory, it's a hypothesis. A hypothesis is an educated guess to explain an observable phenomenon, not necessarily substantiated by facts. A theory is a hypothesis that has been tested by science and factually supported. So this may be an unprovable hypothesis, but think of this. Our ancestors will not encounter this once or twice, but millions upon millions of times over millions of years. We're hungry on the savannah, we're looking for food. The most common things that primates do is look for grub, insect larvae. Dung is full of it. The mushrooms then rot with insect larvae. This is not a happenstance or just a rare coincidence. This would happen with such a multiplicity of events that I think is a strong hypothesis for explaining the sudden enlargement of the human brain. So a number of studies in the past 10 years have proliferated in the scientific literature. Psilocybin stimulates neurogenesis and the extinction of fear conditioning. And it causes neurogenesis and the proliferation of TIPS. Now, extinction of a conditioned fear response is really important. This is related to PTSD, of course. They did experiments with mice associated with an acoustical signal that would cower in fear because they expected punishment. Upon dosing the mice with psilocybin, they would overcome that response. They could be retrained and they could let go of their association with this, with the fear response. Now, an extraordinary graphic here. Now, this is your brain normally. This is your brain on psilocybin. Which brain do you think would be better at being able to strategize, to invent, to be creative, to respond to catastrophe? I think I'll choose the one on the right. So now let's go forward into time. The famous bee shaman of northern Nigeria is it from the Tisilian and Jar Plateau. That's an actual pictograph, 5000 BCE. And this has been redrawn by my friend Jonathan Meter. Many of you may not know that beer used to have mushrooms in it, but the Beer Purity Act of 1560 made mushrooms illegal to be put into beer. A struggle between Catholicism and the pagan religions of Europe, where people would make psychoactive meads and honey with mushrooms, and they'd celebrate together in contact with nature and God, until the church came in to run interference, to pay tithing so they could control your gateway to the heavens. This is the struggle of humanity. So, going forward into the 1950s, this is my brother John holding a mushroom called Psilocybe semilantiata, and Life magazine portrayed R. Gordon Wasson with Maria Sabina holding and giving him the mushrooms. And this is a codolith from 400 years BCE, where Demeter is giving Persephone a mushroom that she ingests before she goes into the underworld, speaking to the origination myth of the climates. But notice how they present the mushrooms. Présentier. You give a sacrament with intention, with respect. This is important. This is a common gesture of introducing a neophyte to a sacred mushroom. 1957, millions of Americans received Life magazine, which was a field guide to psilocybin mushrooms of Mexico, right in the middle of the Cold War. And this is the first introduction. R. Gordon Wasson would only write the article if no one would change anything in it. Life magazine got to choose the title, and that is where the magic mushroom was first used as a phrase in the literature. But the use of mushrooms in Mesoamerica goes back even further in South America. Mushroom stones have been found in the western slopes of Guatemala. These were shrouded in mystery. They were like family heirlooms or a family coat of arms. They could have been property markers. They could be invoking rain. With rain, then you would have crops and have mushrooms. But the conquistadors and the Spanish, under edict from the Pope, had these Spanish destroy these by the thousands. Because the Spanish brought over the European diseases, smallpox, flu viruses, syphilis. The shamans could not respond in time. But if you converted to Catholicism and began the promise of an afterlife, then many of the Mayans and Mesoamerican peoples converted. Those that did not convert then were snitched upon by those that were converted, and so they buried them in the fields to hide their secret mushroom cults. I am so honored to be the caretaker in this lifetime of 17 mushroom stones from Guatemala. I intend to return them to the Guatemalan people, but I've had several people tell me who are experienced the Guatemalan government's not to be trusted. These will just be sold off in the art market. They're precious and sacred to me. I've had them in boxes. A shaman visited me and said, Paul, they want to get out. So I put them out in this array. And my joy came to my heart because I have a Mayan family, a heritage that for the first time in history, they're all sharing the same place. This one in the center is 2,500 years of age. These other ones go from 2,500 years to about 1,000 years ago. I grew up in a small town in Ohio. This is my brother John, who went to Yale. I was the youngest one in the family, Columbiana, Ohio. We lived in a large house. In the basement was an extensive laboratory, 3 rows of chemical shelves. My brother John was a true chemist, and before he went to Yale, he was very much embedded into chemistry. We had the aircraft carrier Intrepid's radio, their main radio. My dad was on the Intrepid aircraft carrier in World War II. And so my brother John would not let me play in the laboratory. He was a serious scientist, but I could play with the radio, listening to coded messages across the Iron Curtain. I admired and loved my brother John so much. He went down to Mexico, came back with incredible stories of tripping on magic mushrooms. And I, being the youngest one in the family, just couldn't wait to join my brother on some of these adventures. I received the Invention Ambassador Award from the American Academy for the Advancement of Science. I was so excited to call my brother up. John, I've been recognized. My work is serious. Because John, being the Alpha Brothers, that's what they do, Kind of always like, your work is not that important, Paul. And yes, it is, John. And so finally, CIIS gave me the Invention Ambassador Award after, going through a gauntlet of peer reviewers. I called up my brother John, excited, and said, John, this is it. Objective validation of my science. I called him up on the night that John died. He died from cardiac arrest. I don't know if he got the message or not. But John was a huge influence in my life, and I like to pay respect to him. So I went on to the Evergreen State College, and my 4 primary mentors were Dr. Alexander Smith, University of Michigan, Dr. Daniel Stuntz, University of Washington, Kit Skates in Post Falls, Idaho, and Dr. Michael Bew. These 3 have passed on, but I came into their fold when I was about 19 years of age, and these 2 individuals were politically conservative people. So it was amazing they took me under their wing because this is what I look like. Your suspicions are now confirmed. So So Dr. Michael Bugh, a nerdy, great a chemist, a mycologist, who wrote the protocols that could accurately determine the presence of psilocybin. He mentored three of us, Jonathan Ott, Jeremy Bigwood, and myself. We collectively went on to write about 13 or 15 books. Extraordinary. We were covered by a Drug Enforcement Administration license. I then went on to discover and name 4 new psilocybin active mushrooms: Psilocybe leniformis, variety americana, Cynofibulosa, Wiley I, after Dr. Andrew Weil, one of my best friends, and Psilocybe azurescens. Other species that are very prominent in the Pacific Northwest and in California, to a degree: Psilocybe stuensii, Psilocybe ellenii, and Psilocybe baeocystis. Johns Hopkins and Roland Griffiths' supervision published an article, a series of clinical trials approved by the FDA and the DEA, finding that volunteers under a clinical setting found that ingesting these mushrooms had profound spiritual significance, even 14 months later. The majority of those people had a profound positive experience. A few people who did not have a positive experience had a negative experience. The negative experience did not extend beyond the duration of the experience itself that one day, whereas the positive experience has extended many months, even years subsequently, as being something that was extremely powerful in their lives. A retroactive survey looking at 480,000 people surveyed by U.S. Department of Health and Human Services found that there was a distinct relationship between psychedelic use and criminal behavior, causing this is their prisoners, retroactively in penitentiaries, a 27% decreased odds of the past year of larceny and theft if they had one psilocybin experience in their history, a 22% decrease of odds for property crime, 18% decrease of odds for violent crime. So that subset of the population who are psychedelically educated with psilocybin mushrooms has statistically significant reductions of criminal behavior. Moreover, there was an association with an increased nature readiness in another study and a decrease towards authoritarian political views. Wow, I know somebody who could really use this. So I think we can then conclusively say that psilocybin induces courage and kindness. And moreover, these are leadership skills. Don't you want to follow a leader who has courage, but who's kind, who's empathetic, who has your best interests in mind, not their own? Those are the type of leaders we respect. Those are the type of leaders we should support. Moreover, we become better citizens. At Johns Hopkins, in a clinical study with Roland Griffiths and his team, this has now evolved into looking at psilocybin-assisted therapy for psychiatric disorders that are otherwise not treatable. There is a reset mechanism that's been proposed. Again, the extinction of the fear response. And that treatment-resistant depression, of which there are several categories that resist conventional treatment, there's an urgent need. People who are clinically depressed and are traumatized stress our social services, our health system, families, relatives, employers. The ramifications throughout society are hard to calculate, even to underestimate or overestimate. Currently, there is a huge surge in microdosing, in using psilocybin at low doses in order to increase creativity by coders, particularly in Silicon Valley, to write better code, to think of new strategies, new ways of being able to do things more efficiently. I call this epigenetic neurogenesis, the using of psilocybin as a nootropic vitamin. This, I think, has enormous potential for us all. I'm going to show you now something I've never shown in the United States. I debated whether I should show this to you. I said, screw it, I'm going to show it to you. Greetings, and meet Psilocybe azurescens. Psilocybe azurescens is probably one of the most potent mushrooms in the world. It contains psilocybin and psilocin up to 2% of its dried mass. Now think of that. 2% of the dried mass of this mushroom are psychoactive crystals. Why would a mushroom produce so much? We don't know,
but it certainly has attracted the interest of humans. The bluing that you see here is a bruising reaction. It's indicative of psilocin as it degrades. And the more bluing you see, the more psilocin there once was. Now, psilocybin dephosphorylates into psilocin, and when you ingest these mushrooms, psilocin becomes a serotonin agonist. It means that the psilocybin, or the psilocin, becomes a temporary neurotransmitter, opening up the floodgates of the senses. Now, this mushroom is sinuous. It's got a sinuous stem, which means it bends back and forth. It is bluing very, very strongly, and it has these very indicative spore color here on the annular zone. And the spore color is purple-brown, and the mushrooms are bluish. Those two features in combination pretty much de facto determines its psilocybin. Now look how bodacious the rhizomorphs are at the base of the stem. This is a large psilocybin, by far the largest one that I know that grows on wood chips in the Pacific Northwest. It is now a popular one to have in your backyard. It's just fun, it's just naturalized in the woods here. And this is a beautiful fruiting of them. And the psilocybins, many of the woodland psilocybins have this chestnut brown to caramel color. This one is unique in that it's got these umbos, and there is a broad umbo, and the cap is very circular. The bruising reactions just from impact of rain, perhaps. This mushroom is one of the most fascinating and interesting ones to grow. Those who choose to partake of this mushroom should be warned. These are exceptionally potent, and oftentimes they can cause temporary paralysis, loss of muscle control. So that is not a good thing. It seems that most people who boil this mushroom in hot water, those symptoms seem to be alleviated. But this is clearly a sacred species. I love just personally touching it. This is not a mushroom that I enjoy eating. It's almost too potent for me. But it is a species that I greatly admire. I love touching it. I love handling it. I love seeing it. And it's a great indicator of the habitat in my magical mushroom forest that is very conducive to spiritual experiences.
Wow. So many of you know about psilocybin cyanescens. Most of you people who know about psilocybin cyanescens don't know about psilocybin ascharosens. Look at the difference in size. This is just phenomenally large. Now, I'm going to also show you something I've never shown in the United States, but I came up with a unique extraction method that's totally counterintuitive, using ice cubes. And the ice cubes are melting at 34 degrees Fahrenheit, just above freezing. And over 4 or 5 days, it does a cold water extraction, pulling out the psilocin and the psilocybin. I show this especially to those people who have DEA licenses, some people in the audience do, for therapy and the use of psilocybin mushrooms. This might be a good way of starting a fractionation pathway to lead to better genetic compounds. Now, Michael Pollan's I mentioned, and it was mentioned at the beginning, has come out with a new book. It is a great introduction for neophytes into the use of psychedelics, mushrooms in particular. And I think Michael's done a superb job in building a bridge. But there's another mushroom I want to talk to you about, and that is lion's mane. The psilocybin mushroom may be the first smart mushroom that we can benefit from, based on our primate ancestors and neurogenesis. But this mushroom, lion's mane, is a legal mushroom that has the most potent nervostimulant factors ever found: hericenones and aronacenes. Now, there's been several clinical studies on this mushroom, increasing cognitive impairment, double-blind placebo-controlled studies that found that the use of these mushrooms, 2 to 4 grams per day, with patients suffering from dementia or cognitive impairment or depression, significantly and statistically improved after using them for about 23 to 25 days. Upon stopping their ingesting of these mushrooms, they then reverted. We all are suffering from neuropathy as we age. We all are suffering from different forms of dementia to different degrees. Many of us will suffer from Alzheimer-like symptoms. And so looking at the nerves, what happens, it's classically, Alzheimer's is a big complex, but one of the common features is the formation of amyloid plaques. And the amyloid plaques form and then interfere with the signal transmission along the myelin that is coding the axons of the nerves. The myelin is a conduit of nerve signals, and the interruption of that myelin sheath on the axon of the nerves interfere with neurotransmission. What's extraordinary is that in a series of experiments, it's been shown that the introduction of lion's mane mushrooms removes amyloid plaque formation. Now, this is 2 experiments have been done that are extraordinary, also in laboratory with mice. And I want to just quickly describe them. And I find these to be very simple tests that really speak to changes in behavior at a fundamental level. One experiment, a group of mice were put into an arena, 100 mice, and they had a corridor going out with a wide choice test. Left side of the corridor went to food, right side did not. The mice very quickly learned, you go out, you want to get fed, you go left. Well, then they injected a polypeptide that would induce amyloid plaque formation. And after a few weeks, the amyloid plaque developed, demyelination occurred, axon signal transmission was interrupted, and the mice then became confused and then randomized. They couldn't remember which way to go. Short-term memory loss. Well, another experiment, and then they fed them lion's mane mushrooms, and then about 3 to 4 weeks later, the mice then remembered which way to go to get food. Upon sacrificing different sets of those mice throughout the study, they saw the presence of amyloid plaque, and then after the mice were fed lion's mane mushrooms, the amyloid plaque was resolved, signal transmission reoccurred, and the mice remembered the path to go. The other experiment I find is more interesting. 100 mice in the arena, they put in a toy, the mice that explored the toy got really excited, they normalized after a while, they've seen the toy for a while, and then when you put in a new toy, they got excited again. They sat around with little clickers, and how many points of contact, how many mice. Also injected them with this amyloid plaque forming polypeptide that's toxic. Amyloid plaque formed. When they put in the second toy, the mice showed very little interest. Loss of novelty, loss of curiosity. As dementia and Alzheimer's-like symptoms progressed, sacrificing the mice again, they saw the amyloid plaque formation. Upon giving those mice also, basically 5% of their food ingestion was lion's mane mushrooms. Then after 3 to 4 weeks, they found that the mice then engaged and got excited again about exploring a new object in their arena. This is what happens, this is what should happen in trying to fight Alzheimer's, is being able to regain your short-term memory in order to regain creativity, inquisitiveness. People who are creative are happy. Happy people are creative. It's a self-fulfilling prophecy. And when dementia then, unfortunately, gets out of control, then depression and lack of creativity, and it's a spiral downhill. So I think we have a unique opportunity here of combining 2 groups of mushrooms. And I propose to you a nootropic vitamin complex formula, a stacking formula for epigenetic neurogenesis of using psilocybin and psilocin or psilocybe mushrooms combined with iridescens or lion's mane mushrooms at these proposed doses, stacking it with niacin. Now this is really important. My brother John, when he came back from Colombia, he had the federales were coming, they had to come down off of psilocybin, they took niacin. It was well reported in the 70s and 80s that niacin would counteract the effects of a bad trip on psilocybin or LSD. And if you take high doses of niacin, what happens? You get a red flush, you itch. And so it dawned on me, wait, this is an opportunity of driving neurogenesis to the endpoints of your nervous system. If the vascular system is in attack, then you can drive neurogenesis to the, oftentimes neuropathy occurs at the fingertips and the toes. And the idea of being able to drive the neurogenic compounds, like the iridescens and psilocybins to the end branches, regenerating myelin, being able to proliferate new nerve tips, which is what psilocybin does, regeneration of myelin on the axons, which the lion's mane does, and by stacking it with nicotinic acid, vitamin B3, it's like the anti-abuse with alcoholics. People trying to abuse this will get such a severe red flush, reaction that it would be such a detrimental for them trying to experiment to get high from this. I think there's an opportunity here for us to provide a new way of fighting neuropathy, fighting dementia, perhaps fighting and forestalling Alzheimer's, but moreover to increase intelligence in young people, in coders, you know, in our strategists, in business, in the military. This has an opportunity to increase the levity of society, to make us happier, more interesting people, to have an extension of gratitude, to open our arms to people not of our culture, not of our race. This is a substance, I think, that has enormous possibility. Now, why microdosing? This is amazing, and so many people miss this article. Mice injected with low doses of psilocybin extinguished the fear of conditioning significantly more than the higher doses, and neurogenesis tended towards an increase at low doses. So that's why I'm proposing of using these mushrooms at basically 1/10 to 1/20th of what you would feel liftoff to be. So you can use this repeatedly. So there's a big need for us to be able to clinically use psilocybin in an affordable fashion. The current cost of psilocybin per gram is $7,000. Extraordinary. So by growing these psilocybin mushrooms under controlled conditions, under licensed practitioner, with DEA license, regulated by the FDA, I think it has a unique opportunity. The difference between a toxin and a drug is often dose. And this is a good argument, I think, and a good hypothesis. It's a theory. It's substantiated by fact that each of its elements strung together, I think, is something that we should try. So, and it increases your respect for the ecosystems. It increases environmental awareness. It puts you in contact with the all of nature, the fabric from which we arose, the fabric into which we descend upon death. Fungi, the grand molecular decomposers in nature, we all will be rendered by fungi again, get used to it. So, all of that now, believe it or not, is mycofactor A. I'm going to now present to you a mycofactorial equation. And when you string these mycofactors together, you'll understand the epiphany that I've had that is extraordinarily interesting. Let's look at the ecosystem. After 70 years, 75% of the carbon stored in soils is fungal, living and dead. The majority of the carbon on this planet, biologically produced, is in fungal networks underneath your feet. The biggest strategy to combat climate change is to increase the growth of fungi in the soils, and fungi make soils. Fungi decompose giant trees, logs, you all know this. My partner Dusty and I go into the old growth forest frequently. This is where I tell my mother, who's a charismatic Christian, where we go to church on Sundays. Paul, have you gone to church? Well, Mom, I went to church on the old growth forest. It was wonderful. So we go into the old growth forest and we bring back mushrooms. We have an extensive laboratory now, about 700 strains, over 500 species. We've been collecting these mushrooms. We grow them in the mycelium in vitro propagation. One of the most well-studied mushrooms in the world is turkey tail, Tremades versicolor. It has the greatest number of scientific references. In particular, turkey tail contains a protein-bound polysaccharide called PSK. And we were involved in a clinical study and applied with NIH with a group of other researchers. I was one of the co-PIs, principal investigators, and we received a grant from NIH for $2.2 million for a phase 1 breast cancer clinical study. Now it's called versicolor because it's variable in color. That's why it's called versicolor. And we compared the mushroom fruit bodies versus the mycelium. There was a conflict of interest of having me being a supplier and a co-PI. I was asked to make a choice to do one or the other. I chose then to be a supplier. They said, well, how do we know your mushrooms are better than other mushrooms from like China or someplace else? So we did an actual test comparing it to PSK side by side, And thankfully, we came out on top. Moreover, we had a chain of custody with the exact specimens that originated the cultures that led to the growing the mycelium or the fruit bodies that could be tested. It's so important to understand your source. So many supply chains are mixed from multiple growers and sold in the spot market where the price being driven down is the main motivation, not quality. Now, rather than describing this further, I'm going to show you a short little video from TEDMed where I presented some of the data. Another mushroom empowers the immune system, and this is turkey tail. This hit home to me very personally in June of 2009 when my 84-year-old mother called me up and said, "Paul, I have something very serious to talk to you about, but you're always so busy." It's a terrible thing to hear from Mom. I said, "Mom, what's wrong?" And she's a very happy, genuine person. She goes, "I'm worried." And my mother's deeply religious, has not seen a doctor since 1968. She said, "My right breast is 5 times the size of my left. I have 6 swollen lymph glands the size of walnuts." And her voice started shaking, and I'm not ashamed to admit that I started crying. "Why didn't you tell me sooner?" We spent a large part of June at the Swedish Breast Cancer Clinic in Seattle. The oncologist examined her, and upon the second examination, she had a 5.5 centimeter diameter tumor. It metastasized, it went to her sternum, it went to her liver. She had stage 4 breast cancer. The doctor gave her less than 3 months to live and stated it was the second worst case of breast cancer she has seen as a doctor in 20 years of practice. We had the Circle family meeting. Many of you have gone through this. My mom announced that she bought a pine casket, the cheapest one that she could find, because she was going to heaven. But then the doctor said, "You know, you're too old to have radiation therapy. You can't have your breast removed. But there's an interesting study on turkey tail mushrooms at Bristol Medical School. You might want to try taking those." And that's my mother goes, "Well, my son's supplying those." So she was put on Taxol and Herceptin, wonderful drugs. And then she started taking 8 turkey tail capsules a day, 4 in the morning and 4 in the evening. And that was in June of 2009. And today, my mother has no detectable tumors. And I like that. Came up on stage in January of 2010. After 5 years of no detectable tumors, physicians don't like to use the term cure, but it is likely that you're not going to die from the same cancer that was first detected. 5 years having no sign of any tumors, my mother then went in and upon visiting the physician, left me this voicemail.
"Hi, Paul. Everything's gold. Everything's wonderful. Past all the flying colors. So thank you for your prayers. I love you, and I'll check in with you later. Bye-bye."
I just spoke to my mother a few minutes ago. She sends her greetings. She's approaching 93 years of age. And Mom, if you ever hear this is how much cream she has in her coffee. This is how much coffee she has. And she loves ice cream. And I said, "Mom, you've got to start eating more vegetables." She goes, "I don't want to hear from you telling me about eating my vegetables, you know?" Okay. So, my mother, I'll accept this. My mother believes that Jesus sent me to discover the mushrooms to save her life. And I'll take all the help I can get. So, there's no greater honor in life than saving the mother that gave you life. So the clinical study was done. There's a stepwise increase in the amount of natural killer cells, more significantly CD8 and cytotoxic T cells. Statistical significance is extremely high. This was then published in an oncology journal. It got translated and published in several other medical journals. And PSK is the compound that is the beta-glucan that's in these turkey tail mushrooms that is thought to be responsible. Combining with Herceptin, they found that the turkey tail mycelium combined with Herceptin potentiated Herceptin, made it work better. Interviewing with Julie Smith, her oncologist, my mother was living in Winthrop, Washington. She came to Swedish Hospital in Seattle. The oncologist there said, you have to be treated in Ellensburg, Washington, over the mountains. You have to have a new oncologist. And my mother and I talk, and she goes, should I tell my new oncologist about turkey tail? And I go, no, please don't. As an abundance of caution, if the doctors are not educated, they're gonna advocate against you taking any supplements. The other doctor at Swedish Breast Cancer Clinic knew of the clinical study. She was up the learning curve. So Julie Smith, upon interviewing my mother, she was asked several questions, and she gave me answers I did not know about. My mother had no loss of appetite, so had no nausea. She had no brain fog. These are classic symptoms that are associated with chemotherapy and radiation therapy. So I had to slowly, over time, educate doctors who are so busy. I can't blame them. I'm immersed into this subject. This is my life. I've put up a reference website, and I update it every month. It's about 100 pages long with 400, 500 references with abstracts. It's at mushroomreferences.com. You know, it's unbranded, it's not promoting any product, it's just pure science. And it speaks about some of the most important references. Now let me explain what a beta-glucan molecule is. A beta-glucan molecule is a vast molecule of polymerized sugars that are chained together that branch. This is the molecular scaffolding that gives a mushroom its structure. It's like building a house. It's the wood of the house that you're building. After advocating this for a number of years, thankfully some of my other co-authors decided to do a test. Because I said that scaffolding had embedded in it all sorts of other constituents that are pharmacologically and immunologically active. We should study those. But how do you separate these? Well, the beta-glucans are massive molecules. Anywhere from, a few tens of kilodaltons to thousands of kilodaltons. They don't make it into your bloodstream. You can't digest them. But the components that are dormed within these molecules can be cleaved off by enzymes. So a group of scientists then used lipases. These are, PSK is not a pure compound. There's no fingerprint for it. The variability in the size of the molecules is huge. But using lipases, they would cleave off these compounds, these phenolic compounds in particular. And when they did so, they found that PSK was decreased by 83% in its immunological response in patients. By removing the lipids from the scaffolding of the beta-glucans, you depotentized it. Now, these polymers of sugars in these lipids can be broken apart. This is what happens in digestion. The beta-glucans go through your system. Dendritic cells are also stimulated. There is a fungal pathogen model that many physicians subscribe to. You eat a fungus, your immune system thinks you've eaten something poisonous, and it sends out an alert, and you get a cascade of an immune response. I don't think it's like that. There's 250,000 species of fungi, 14,000 species, there's 1.5 million species of fungi, about 150,000 species of fungi are mushrooms, 14,000 of them have been identified to date. Our ancestors over millions of years sampled these mushrooms, and a fairly good selection criteria were able to narrow down the field of potentially good mushrooms to about 20 to 30 species, from 14,000 that are known, 150,000 that are predicted to be out there. And we were able to match those mushrooms with the microbiome, that were able to elicit an immune response. These are not fungal pathogens. These are edible, medicinal mushrooms that have been culled from nature and selected by our ancestors to have proven benefits. So this is something that we've explored to great detail. And then another mushroom that fits into this category is Agarikon, the one that I showed earlier, the longest living mushroom in the world. I received an award from the National Geographic. They want to do a story on the search for Agarikon. And they want to come up in January. They're from New York. I go, you can't come up with an old growth forest in January looking for Agarikon. There's 12 feet of snow. So we come up in the summertime. So they did, and we went in a motor sailor with a Zodiac. And I have to say, I lied. The photojournalist asked me, how likely we'll find Agarikon? I don't want you to take me to a spot you already know. I want to have the adventure of discovery and eureka. That's what the story will have life to it. And I lied, and I said, 50-50 chance. 1 out of 100 forays in the old-growth forest will I find this rare species. Dr. Michael Bugh, my professor, after 40 years of going a dozen or more times in the old-growth forest every year, found this first Agarikon the year before last. That's how rare it is. So he came out, and some of the people here in the audience were on this trip with me. We were on the motor. We're on a boat that went up the inland passage of Desolation Sound in British Columbia. We looked for Agarikon. I thought, well, they grow in big old-growth trees with bald eagles, and they look like a giant bee nest, so with lots of binoculars, 10 people, we should be able to find one. That was my logic. We looked and we looked and looked. Yeah, look at one tree, 5 seconds, nothing. Another tree, 5 seconds, nothing. You do that for several hours, you get retina burn. You know, you're like, oh. And so we were motoring, and then our skipper said, well, it's time for lunch, but let's go over to a First Peoples site. There's some pictographs, we don't know what they mean, but it's a really cool place, you know, we can hang out and have lunch. So we're motoring over there, and one of my employees, Jim Goen, goes, sees this tree, and he goes, there's one. We found it. Well, he found it, you know, we were with him. And this one is so extraordinary because it was attached to an upper branch, and the attachment was here. It detached, fell onto this branch, teeter-totter, and then when it was still alive, the mycelium regrew back into the branch, and then it grew 2 legs. No wonder it's called Elixirium ad longum vitam. This is crazy. So, Eureka experience, the photojournalist was excited. Oh my gosh, this is really exciting, this is great. And then we're there for a while, and this is like a 30-foot overhang, so canoes can be brought up. And there's, you know, you're out of the rain, you're right where all the salmon are, it's protected, you know, from the elements. And we're there for a while, and we see this rock. Wow. I'm such a Luddite. I look at this rock, I go, that's really interesting. That rock looks like an Agarikon. There's an Agarikon, there's a rock, there's a Agarikon, there's a rock. So, whoa, we find this rock that looks like an Agarikon. Now, how likely is it going to find an Agarikon? 1 in 100. How likely is it we'd find it at a First People site that seems to be sacred and spiritual that just happens to have an Agarikon there? I don't know, 1 in 1,000. Now, how likely we would find it, you know, with all these other features, look at this rock. And then there's these pictographs. Now, Scott Franzbaum is director of the Institute of Tuberculosis Research at the University of Illinois Chicago. He saw an article I wrote on Agarikon and Dioscorides mentioning that Agarikon was a treatment against consumption, later to be known as tuberculosis. He's very interested in finding cures to XDR, multi-drug resistant strains of mycobacterium tuberculosis, for which there are very, very few drugs, and it's killing millions of people a year around the world. Scott came with us. Well, this pictograph at this site that I'm showing also resembles strongly that of the origination myth of the women with Haida culture. And Agarikon were found on as grave guardians on shamans' graves and the North Coast Indians and the Haida to help the Indians pass into the afterlife after the shamans have died. So the Greeks and the First Coast peoples discovered that Agarikon was a powerful medicinal mushroom of spiritual significance, highly variable in its form. Now, I met Gujau, who's the president of the Haida people, the Haida Gwaii. They don't call it the Queen Charlotte Islands, that's the name of the ship that brought in smallpox. It's the Haida Gwaii. I felt it was my mission to return the knowledge of Agarikon to indigenous peoples. I met Gujau, we became best friends. I stayed at his house for several days, traveled around the island. They go, where are you staying? I'm at Gujau's house. I go, whoa, that's good. You're good. And so I talked to Gujau, and after a few days, he goes, you know, let me be straight about you. You gringos think us Indians know everything. We did know a lot. But we had 4 pandemics, 2 waves of flu viruses, 2 waves of smallpox, 10 to 20 years apart in the late 1800s. It wiped out our elders. We wiped out our oral traditions. My grandmother knew a lot about this. So I felt, you know, it's really important to bring back the knowledge of Agarikon. Now, the origination and myth of women and the Haida culture, there's Raven on the sea canoe, traveling on the sea of eternity, and Raven cannot get help from the bear, the killer whale, the eagle. No one can help Raven succeed in her quest to find her genitalia, except for Fungus Man in the back of the canoe that would help steer the canoe to her ultimate destiny. Now, to be truly, absolutely accurate here, there is a competing fungus, the artist conch, which I think is a reasonable thing. Now, we know the grave guardians were carved with Agarikon, there's no doubt about that. But the argillite plate here from 1918, is Fungus Man Agarikon or is Fungus Man the artist conch? It makes sense, it could be the artist conch, but you can draw a map on it. You etch this, you draw with a knife or stick, and you can etch out, you know, a map of what fjords to go up in order to find, you know, these special sites. We don't actually know. But it's been something I've dedicated my life to. Ever since 1980, I've been collecting Agarikon strains and putting them into a cultural library. My first strain collection, as you'll about to hear, it only existed through about 7 specimens. Sometimes very hard to get to, way up in old growth trees. As my friend Scott Baker, he was a tree climber, climbed up, and this is one of the biggest Agarikons that I've ever seen in my life. And we take a tissue culture from the bottom of it. We don't have to collect the mushroom. But sometimes we find them broken off, or if there's logging or development or roads being put in, we hear of Agarikon in the area, we will pick it because it's going to be destroyed. Scott Franzwell with his friend Mel, this is the fresh form, this is the ghost form. The ghost form biochemically changes after it's been harvested and turns white. This is the biggest Agarikon I've ever seen, a real typical Northern California kind of guy. And this is east of Sacramento. I was going in a forest there that was going to be cut. They called me up saying, we found this massive Agarikon. I said, don't pick it. They go, well, they're going to log it. I go, pick it, you know. And I want to get a sample. They sent me a sample like this big. So I was able to get this one in culture. Okay, working with Scott Franzwell, he's interested in finding anti-tuberculous compounds. So we did classic pharmaceutical discovery using bio-guided fractionation. You take a natural product and you split it. Now, water pulls out beta-glucans, polysaccharides. It's a highly polar solvent. And at least water-loving, non-polar solvent, hexanes and oils, pet ether, are pulling out lipids. They're on the other, both on the other ends of the spectrum. So when you do hot water turkey tail mushroom extraction, you don't pull out the lipids. Lipids are not soluble in water. So when you partition the lipids, as I showed you before, away from the beta-glucans, you're depotentizing the immunological activity. Nevertheless, it's a classic decision tree that pharmaceutical companies, natural products researchers do, and when they split into 2 fractions, they test each fraction, was the potency of tuberculosis increased or decreased? Logically, the path that gives you increased activity, then you further study that one and fractionate it out further. It's more than 200,000 molecules, unique molecules in mushrooms. This is a painstaking process. The University of Illinois Chicago, Scott Franzwell team, we worked on this for more than 5 years. Lo and behold, we found it. We found and published in the Journal of Natural Products a novel chlorinated coumarin, highly active against tuberculosis, heretofore unknown in science. So we did this. It took an enormous amount of time. They're funded by the Gates Foundation. You know, they spent hundreds of thousands of dollars just to find this one new anti-tubercular agent. So we explore the old growth forest. We take GPS coordinates. We take a small sample of tissue. We get it in a little cork bore. We take it into the laboratory, and then we generate mycelial cultures, 4 different strains of Agarikon. I've been writing on this, and then in the journal Herbalgram, in the June of 2001, I do a survey on all the antiviral properties, not bacteria, antiviral properties of mushrooms ever published in scientific literature. A whopping 1 page long, and most of it is in half photographs, so there's only like 6 references here. So I published that in June 2001. September 11th, 2001, we had the terrorist attack. Soon thereafter, we had the anthrax attack. A physician with a BioShield biodefense program set up with more than $2 billion approved by Congress, spearheaded by Dick Cheney, then sought to find protections against weaponizable pathogens, including bacteria and viruses. Viruses were the biggest concern. So they saw my article, they approached me and said, Paul, we want to sample your culture library for potential new antiviral compounds. Will you participate? I said, happily so. And so I submitted fruit body mushroom extracts, mycelial extracts, side by side, sent them the first set of 100 samples. Got the research results back. Negative, 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 negative. Got the sample number 77, highly active against pox. 79, highly active against pox. 88, highly active against pox. I didn't tell the government what the samples were. I had encoded it in a register. I looked up those numbers, and they all corresponded to Agarikon. Agarikon was highly active against pox viruses. This is like extraordinarily exciting. So the conclusion, the research then continued. You can listen to a National Public Radio interview with myself, the Deputy Director of the FDA, and the lead virologist, Jack Sechrist, of the BioShield Biodefense Program from Southern Research University. But there's a vetted press release. It says that of the more than 200,000 samples prepared, we're in the top 10 of novel antiviral activity samples. We're the only natural product to have activity. In fact, I found out later is more than 2 million. We then worked with the University of Mississippi National School of Natural Products Research, School of Pharmacy, Dr. Samira Ross. We began to do then the biogated fractionation, just like we did with tuberculosis. The solvent system, water, hexane, polar, non-polar, testing fraction. If it increased in potency, we follow that fraction. They did the work for more than 5 years, delimiting more than 200,000 molecules, and lo and behold, we found brand new anti-smallpox molecules heretofore unknown to science. More potent than cytophavir, the preeminent anti-pox drug control, with no adverse cytotoxicity effects. This is huge, folks. Smallpox killed millions upon millions of people. It killed the Haida. When I told Gujao this, you know, he was excited, but he said, our shamans did not have time. The smallpox came on so fast, we didn't have time to respond. They were so close to having the antidote to smallpox. It's not the fruit body, it was the wood that was full of mycelium in the trees. If they took that material and had made a tea out of it, they could have protected themselves. So this is open source for the world. Hopefully smallpox will never come back, but we think we have some very, very powerful antiviral drugs. Now this is interesting to me. A natural product has dual activity against bacteria and viruses. It's really not really heard of in medicine when you're looking at single agent molecules with a targeted effect. But the fact that it has a broad shield of protection against viruses and bacteria that are pathogenic, I think is medically useful. Then the BioShield program approached me and said, flu viruses are our biggest concern now. Smallpox, hopefully, you know, is not resident in nature. It's present in a number of laboratories around the world. I said, can we test your samples against flu viruses? The flu viruses cause massive pandemics. We just had a bad flu season. A friend of mine, Dr. Michael Vallis, in the audience, is one of the worst flu seasons that he's ever seen, working for Kaiser. And 2.5% of the world population died in 1918. I think most of you heard about that. H5N1, when it does infect people, kills more than 60%. A new one, H7N9, also kills more than 70%. So we then started sending samples after samples after samples to the BioShield Biodefense Program, controlled by the Department of Defense, National Institutes of Health, and the U.S. Army Research Institute of Infectious Diseases. There is a selectivity index. If a compound has a selectivity index of 2 or more, that means it selectively kills the virus without harming the host cells. 10 or more is considered to be very significant. I found out this past 6 months that Project BioShield ran 2,392 assays on our samples. That's how many samples that they tested that we sent them. I ironically have a debt of gratitude, I can't believe I'm saying this, to Dick Cheney and George Bush for sponsoring this research. But in all sincerity, their sponsoring this research is going to have something even more profound that you're about to see. But people ask, well, is the fruit body better or is the mycelium better? Whole genome sequences that have found the mycelium upregulates and expresses. The genes are much more active, more genes are being expressed and upregulated and turned on in the mycelial state than the mushroom state. Think of it, the mycelium is one cell wall thick, navigating through a hostile microbial environment, We have 5 or 6 skin cells affected with infection. The mycelium has 1. It grows to massive thousands of acres in size. It's 1 cell wall thick, and yet it achieves the largest size of any organism in the world. The mushrooms are usually highly perishable. The mycelium is the immune system of the mushroom. They end the life cycle of the mushroom to spread spores. The mycelium, it takes a long time to navigate through a hostile environment. This makes sense. The mycelium is more pharmacologically active. So in the BioShield biodefense program, using ribavirin as selectivity control, remember, anything over 10 is highly active. This is the ribavirin that's being used against viruses, flu viruses, and then we presented them with our extracts. They're 35% alcohol. We had to dilute them 100 to 1, because there are human cell well assays where they infect the cells, and then they put the substance in the infected cells to see the virus clears and the cells survive and then reproduce without the virus. So they took our extracts, diluted them 10 to 1, 3.5%, 10 to 1 again, it's 0.35%, 100 to 1 dilution of our natural mycelial extracts compared to ribavirin, a pure pharmaceutical control, and these are our selectivity index numbers. More than 10 times more potent a natural product than a pure pharmaceutical. I filed a patent on this. This is my idea. I spent a lot of money on this. I filed a patent on this, and the patent disappeared. In 2004, it never showed up in the patent homepage. After 5 years, 4 years, I asked the patent office what happened to my patent. The Department of Defense captured it as a matter of national defense, quarantined it, took it out of the patent office. For the same reason you can't write a patent about nuclear weapons and publish an application on it. We had to do an intergovernmental agency trace, pull the patent out of the DoD. They went into the review process, and in 2014, I was approved a patent, a composition patent on Agarikon against flu, herpes, against E. coli and staph bacteria. So patents normally get approved in 2 or 3 years. Some of you have patents, you know this is an extraordinary long time. 10 years for a patent to be approved? Well, at Vector, the Vector Institute, which is the Fort Detrick of Russia, where they have smallpox, virologists there also discovered the same thing. But 7 years later, I gave a talk in Washington, D.C. I invited some virologists that I work with, the U.S. Defense Department at Fort Detrick, come to my lecture, and I said, we beat the Russians by 7 years, and a small cheer in the audience, hey! Anyhow, anyway. So, and then other research articles came out showing these polypore mushrooms are highly active against viruses. Now, many of you know about Tamiflu, but did you know Tamiflu has a feedstock problem related to the star anise that's grown in Afghanistan and the Middle East? It produces shikemic acid that comes from the star anise, harvested once or twice per year. The supply chain issues are severe. There's a big flu scare a few years ago. Tamiflu got bought up by all these people in the U.S. government, and Tamiflu was not available to the general public. As it turns out, it was just discovered that oyster mushroom mycelium, in exposure to blue light, I gave you a hint earlier, stimulates the production of shikemic acid, which is the intermediate in producing the inhibitor of flu viruses and the core substance that Tamiflu is made upon. Blue light stimulates antivirals in mycelium. So, this is interesting. That's mycofactor B. It's 5 of these, okay? Bear with me on this. This will start making sense. We have a bee apocalypse now called colony collapse. And the colony collapse is now sweeping the globe. It's been identified as a worldwide threat to food biosecurity. China produces the most beehives in the world, then Turkey, United States, Iran, and Argentina. The loss of bees, wild and domesticated, is such a critical problem. There's been a lot of propaganda telling the public it's not that big of a problem. Folks, if anything, it has not been told enough. It's not been emphasized enough. So many of you know, or some of you know my work with entomopathogenic fungi that attack termites and carpenter ants and mosquitoes and flies and I have 8 patents on this. It's a highly disruptive technology. You can Google Stamets and Monsanto. I think there's 10,000 websites that say Paul Stamets can take down Monsanto. It's not quite true. I kind of like it to be true. But my friend Louis Schwartzberg is a filmmaker, and he was doing a film on bees. He said, Paul, what can you do to help the bees? They're being attacked by varroa mites. And looking at the varroa mites that are injecting viruses into the bees. Now, bees are pollinating an enormous number of crops, 120 different crops that we depend upon, from tomatoes to nuts and berries. I think most of you are aware of that. Whole Foods made this tremendously interesting graphic. Bees pollinate hay, alfalfa, clover. That means all cattle. And many of the ungulates are dependent upon bees for their food stock. Here's your choices at Whole Foods with bees. That's your choices without bees. This is really, really scary, folks. President Obama came out with a memorandum identifying the stressors that are leading to bees in rapid decline: poor nutrition, loss of forage lands, parasites, pathogens, pesticides. Here's an amazing graphic from a nonprofit. In the United States, that's the number of states that had greater than 50% annual die-off of beehives, as reported by beekeepers. Think if you were a cattle rancher and you lost 72%, 84% of your livestock. It's not only economically devastating, it's demoralizing. Then you have to pick up all that material and get rid of it, all the dead carcasses. This is a huge threat. And across the country, now sweeping, there are hotspots. Epidemics become pandemics. Many hotspots join together. Diseases are being spread. Now all wild bees in the world are infected with these viruses, spread by the mite that was introduced in the United States in 1987. There are other stressors, of course, besides mites and these viruses. There are neonicotinoids. The use of neonicotinoids has skyrocketed. It's the most common insecticide now used in the world. It has now created a reduction in sperm quantity and quality, especially over multiple generations. Bayer and Syngenta sponsored a study in Europe trying to prove neonicotinoids are safe. We'll get the best scientists, we'll sponsor some research, peer-reviewed articles, good science. They did it. The scientists came back with a report, and Syngenta and Bayer were horrified. They actually tried to prevent publication. It was published. Enormous amount of press in Europe. Syngenta and Bayer double-step backwards. It's not like the neonicotinoids, they are a potent insecticide. They do kill the bees, but the sublethal thresholds then carry over into multiple generations. So when you look at a clinical study of only 20 days, you don't see the big picture of 2 or 3 years. And because of drift of the neonicotinoids into other adjacent lands, into the woodlands, etc., this is such a great thing that's happened. Neonicotinoids, as of this month, have been banned in Europe. Bayer and Syngenta, be careful what you ask for. So the deformed wing virus now is spread throughout the entire world. First coming from Asia. In the past 80 years, it is now infecting all bees in the world. Dr. Jay Evans, a renowned virologist at USDA, has not seen a virus-free bee in more than 10 years. The deformed wing virus is a sinister virus. It not only deforms the wings, but it weakens the wings, so visually the wings look okay. Bees used to fly 9 days. When you see bees on a flower, it's the last days of their lives. They typically live 30 days in their life cycle. In the last 9 days, they're bringing pollen back into the hive. Now it's been shortened to 3 days in the past 10 years. From 9 days to 3 days. The beehives are stressed. The nurse bees then abandon the brood. They're prematurely recruited to go get more pollen because the hive doesn't have enough food to be able to feed the brood. They abandon the brood, and the mites then inject more viruses because the nurse bees cannot take care of the baby bees. So in 2016, 2017, the deformed wing virus has been identified as the #1 virus that's the nail in the coffin of bees. It has just been discovered that when those infected bees visit a flower and collect pollen, they leave the deformed wing virus on the flower. 80% of the benefits that you get, or we get, in agriculture, in pollination comes from wild bees, not domesticated bees. So now all wild bees are infected with this virus. The introduction of the deformed wing virus is a leading contender as a cause of colony collapse, published in a virological journal. The mites are like having a pancake on your back, they're so big. 100% of honeybees colonies are now infected. There's a global pandemic of the deformed wing virus. This is a huge crisis that we face. Climate change is a crisis. The loss of bees are a bigger crisis. You lose food stock, food prices rise, poverty increases, communities become stressed, resources become harder to get. It becomes a breeding ground for terrorism. There's a direct line between loss of bees and pollination services, expenses in food, poverty, and terrorism. So, something very strange happened in my life. In 1984, I was growing the garden giant mushroom in my garden. It's a massive mushroom. It's delicious. It loves to grow in wood chips. I had 2 beehives, and they're about the distance from here to where you park your cars, several hundred feet. I go out to my garden in July, and I look very carefully at my mushroom beds. I can't believe what I see. I see all these bees, and they're moving the wood chips off to the side, and the mycelium is exposed, and I look really close to that. I can see them sipping little dewdrops, coming from the mycelium. I go, oh, they're probably getting sugars. And for 40 days, from dawn to dusk, there's a continuous convoy of bees going from my beehives to my garden giant patch, until the garden giant patch was sucked down to about 1/3 to 1/4 of its depth. They're pollinating their flowers in the landscape, and yet these bees were continually going back and forth. So looking at this, and then realizing, oh, interesting, blue light stimulates mushrooms to form. And it turns out that the mycelium is growing, is producing enzymes, lactases, that are breaking down the wood, breaking lignin cellulose, breaking it down, and the sugars are being produced by the mycelium. That makes sense. But when blue light stimulates the mushrooms and my mycelium comes up to the ground and sees the sky, then the mycelium stops producing lactases, doesn't need to digest anything, is stimulated by light to form mushrooms. So lactases stop, and p-coumaric acid stops. P-coumaric acid becomes really important because a study came out showing that the honey that was collected from beehives that were abandoned. Now, some beekeepers are in the audience. When you spray an insecticide, the bees die right there upon point of contact. But with colony collapse, you go out to your beehives on Monday, everything's fine. You go out there on Friday, and they're all gone. There's a few dead bees, but 40,000 bees disappear. When they analyzed the honey, they found that the honey lacked p-coumaric acid. Now, p-coumaric acid is the chemical trigger that stimulates the cytochrome P450 pathway. All animals use this. You have it in your liver. It's your detoxification pathway. This is what animals have evolved to break down toxins. Without p-coumaric acid, the detoxification pathways in bees were turned off. So they're hyperaccumulating neonicotinoids, pollutants, hydrocarbons, other pesticides, insecticides. They get malaise, they get sick, they're infected with a virus. Now the detoxification pathways are turned off, they're hyperaccumulating toxins. But you can't, when you're sick, you can't take care of your children as well. You can't be as good at hygiene. There's a slippery slope downhill. Then it was found that glyphosates interfere also with the cytochrome P450 pathway. Glyphosates are used in agriculture. Monsanto is a big purveyor of them. Better living through chemistry, so not true. And it interferes with the mineral absorption of plants. It also interferes with yours, and it disrupts your microbiome. All of that is mycofactor number C, or letter C. There's 3 mycofactors here. I'm walking through the woods. I go to the old growth forest, bare grass trees. In Washington State, the timber harvest on state lands funded the schools with a timber harvest. So in the wisdom of the regulators, they put a bounty on bears to kill the bears because they scratched trees, because mushrooms would enter, polypore mushrooms. This one in particular, the red-belted polypore, it would kill the tree, so they killed the bears, so the trees wouldn't get killed, so they could have enough timber to fund the schools. So my neighbor killed more than 400 bears. We have salmon runs right in front of my house. There's not a bear to be seen. And there used to be hundreds of bears collecting the salmon, which we now know the salmon are brought up into the forest, and the phosphorus is being returned, and phosphorus is a limiting mineral in tree diameter growth. Humans are so good at choosing opposite their best interests. So when bears scratch trees, resin forms. Bees collect the resin for propolis. Propolis is then used to patch the cracks in the beehives. There's usually just one entrance into a beehive, so they patch everything else up. So I'm walking with my partner in the old growth forest, the South Fork of the Hoh. I like to orienteer. Really don't get lost for more than a few hours. I kind of like that. I'm like, okay, I'm going to be resourceful. I'll figure this out. Don't panic. It's okay, dear. We're not really lost. We're just temporarily dislocated. So we're going through orienteering, and we find this bear scratch. This is the best photograph of bear scratch I've ever seen. Bam! Scratch. So I tell her, okay, well, if this is true, we should come back in a year or two, and the red-belted polypore should be growing from this bear scratch. This is why they killed them. Kill all the bears. So we did 2 years later, huge amount of work, orienteering in the old growth and finding the same tree again. You know, we didn't have GPS or anything like that. So we finally find the tree that was scratched. And sure enough, the red-belted polypore was growing out of the bear scratch. Whoa. Well, they had part of that story right. Bear scratches introduce polypore mushrooms that kill the trees. And the tree then becomes myceliated, you know, from the red-belted polypore. This is mycofactor D in the mycofactorial equation. I have a waking dream. I'm thinking about the BioShield program. I'm thinking about bears. Fomitopsis panicula is a relative of Agarikon, Fomitopsis officinalis. Mites are injecting viruses into bees. The BioShield program, these polypore mushrooms reduce viruses in humans, flu viruses, herpes, pox. I wonder if these extracts will reduce viruses in bees. So I call up the University of California, Davis. Everybody's here. You should probably know the story. It's probably not the best idea to call up a scientist out of the blue and start the conversation with, I had a dream. I don't have time for you. Goodbye. So I called up Washington State University, talked to Steve Shepard. And I realized this time, I said, okay, I have a story to tell you. I'm at the TED conference. I walk out of TED. I said, sitting down on the carpet, you know, on one of the floors there, I said, just hear me out, please. I need 45 minutes. So I tell him this whole story. Steve goes, go nowhere else. This is fascinating. And he's an entomologist, the head of entomology at Washington State University. And so we developed then making mycelium into a form like honey. And so we made myco-honey, a nutraceutical. And our first tests, then they're called cage studies, 100 bees, you know, into a cage. And these are with the extracts. This is 50% sugar, 50% water. And then in this case, it's 10% of the that volume is extract. And did 1%, we did 0.1% as a longevity stress test. Now the majority of beekeepers feed bees sugar water, 50% sugar, 50% water, enormously thick, you know, sugar syrup. And they feed this to augment the reserves of the bees so they can have enough energy to go ahead and pollinate. Well, we did a number of experiments at Washington State University over the past 4 years. We did the largest beehive experiment in the world last year in February. 532 beehives were tested. And the application is extremely simple. And the graduate students worked until 2 in the morning in order to get all the bees treated on the same day. The first synopsis of our results was very interesting because of the 10 species that we tested, the ones that were the most promising were ones associated with birch trees. Now, I believe shamanistically, mushrooms, plants, including trees, become important spiritually and pragmatically because of a multiplicity of benefits, much like amadou, the fire starter mushroom, the ability for it to be used to ignite gunpowder, the fact you can make fabrics out of it and keep warm. So it turns out that the 4 species, the red-belted polypore that the bears transmit, amadou, which my hat is made of, the red reishi, if you remember from the bioshield results, was highly active against flu viruses and herpes. Chaga was highly active against flu viruses and herpes. So we conducted these experiments, we had really exciting results. And then we decided to do this in increasing numbers of beehives. And the research results led our decision tree as we narrowed the field. So I'm going to show a short 4-minute clip of some of the research that we did.
I'm Steve Shepard. I'm a professor of entomology here at Washington State University in the Department of Entomology, and I work on honeybee genetics and evolution. Honeybees are by far the most important pollinators for agriculture. Approximately 1/3 of the crops grown rely on cross-pollination to thrive.
I don't think bees are properly recognized for the economic benefit that they give to society. I think increasingly they will be recognized as bees become more scarce and food prices climb. But here, one of these beautiful almond orchards, one of the most bee-dependent crops in the world, and the almond industry knows in particular that without honeybees, crops are greatly hindered. So there's many fruits and berries and nuts that are dependent upon bee pollination.
Over the last decade, honeybee populations worldwide have declined drastically. Beekeepers and scientists have been working to try to find out what's the cause of this decline. One of the leading problems facing beekeepers today is the varroa mite. These mites attach themselves to bees, feed on their blood, feed on the larvae, and transmit viruses.
Varroa mites are very good at developing resistance to chemical treatments. The beekeeping industry had a couple of compounds that they used pretty extensively originally, and it's really just a matter of time before mites develop resistance to that compound.
Right here is a sick bee. You can see her wings are deformed. This is a symptom of varroa and a virus called deformed wing virus.
This colony is not going to make it, so even though there are bees here now, this has been destroyed by varroa. There's all these dead larvae in here that will never become adult bees and never contribute.
There's a tremendous need to develop methods to control varroa mites that are sustainable and don't rely on the use of chemicals, allowing beekeepers to get off of a chemical treadmill. I became aware a couple of years ago of some work by Fungi Perfecti and Paul Stamets. They had some fungal extracts, some mushroom extracts that had antiviral properties, so the idea then became to use mushroom extracts to attempt to control the virus titers.
The extracts we're using are coming from the living tissue of this mushroom when it was alive, called the mycelium. And now we're seeing that these mushrooms actually extend the longevity of bees.
Honeybees are critical to agriculture. They pollinate more than 110 varieties of crops. This orchard that we're standing in is 800 to 1,000 acres, and every single one of those blossoms need to be fertilized in a timely manner all at once.
This research experiment that we're doing, I think it's the largest beehive experiment ever conducted in the world. 532 beehives testing the effects of these extracts in helping bees survive.
So what we're doing is we are sampling these beehives to check virus levels, and then we're also treating them with mushroom extracts, which is what we're testing.
So one of the beauties of the fungal extract for controlling the viruses in honeybees is the ease of use for commercial beekeepers. They're used to handling products like this as far as mixing something into their sugar syrup and feeding it to bees. It's very simple to adopt.
My hope is that this research will give us a very important tool in our biological toolkit to help save biodiversity in the ecosystems of this planet. If our ecosystems fail, what do people do for food? And this is fundamental to saving our ecosystems. So I'm hoping that people will recognize mushrooms for the important roles that they play in the ecosystem, of which we're just now beginning to discover before it's too late.
This is a clip from Louis Schwartzberg, who is making a movie, Fantastic Fungi, and it should be coming out in the spring of next year and debuting at, hopefully, the Telluride Film Festival in late August. The results of the bees surviving. The bees only live for about 30 days. We have basically a doubling of the lifespan of bees. More than twice as many bees are surviving. Treated with the red-belted polypore mycelium. P-value of significance is highly significant. The Amadou mycelium that my hat is made from also nearly doubled or more the number of bees surviving, so they could pollinate longer, bring back more pollen, be able to take care of the hive. Dr. Steve Shepard, as an entomologist with more than 40 years of experience studying bees, he's unaware of anything that extends the lives of bees such as this. The 532 beehives. We narrowed the field of species that we tried with Ganoderma lucidum, the reishi, Ganoderma resinaceum, which used to be in this same species group, a sister species, and then Amadou fomes fomentarius. Now, the deformed wing virus is not the only virus being spread by varroa mites. There's a number of other viruses. A severe virus called the black queen cell virus. All queens now are infected with these viruses. The black queen cell virus just prevents the queen from making more babies. Using chaga and reishi mushrooms, we're able to reduce the deformed wing virus by more than 500 to 1 with one treatment.
Wow.
With mycelial extracts of Amadou and reishi, we're able to reduce the deformed wing virus by 800 to 1 with a p-value of 0.001. P-value 0.05 means you're 95% confident the data is good. 0.01 means you're 99%. 0.001, you're 999 to 1,000% confident that you have good data. The reishi mushroom reduced the viruses 80 to 1, approximately 79 to 1, with a p-value of 0.00001. Dr. Jay Evans, who's a renowned virologist who's published widely for the past 30, 40 years, been studying bee viruses, says he's never seen anything that has produced such strong activity against bee viruses as he has with our extracts. The next slide, we blow it out of the water, folks. With the reishi mushroom, we reduced the Lake Sinai virus 45,000 to 1, with a p-value of significance of 0.00005. Hugely significant. We actually have another result. all that we have not reported. We have submitted an article. There's 8 of us co-authors, 2 virologists from the USDA, Jay Evans and Don Lopez, Dr. Steve Shepard, Brandon Hopkins that you saw, 2 other graduate students, 4 of the employees of our company have co-authored a paper in a prestigious journal. All of you have heard of this journal. It passed editorial. It is now off to peer review. These same journals also publish articles on the deformed wing virus and these other viruses as being pandemics. Now, viruses that co-occur create more malaise. It's just not one virus that causes inflammation and disease and challenges the immune system. It's a multiplicity of viruses. To be able to provide these extracts to create an armamentarium of defenses against multiple viruses simultaneously in as little as 1 treatment in 12 days. 1 drop per 100 drops, 10 milliliters per liter. That's how little of this extract that you need. Now here is something I think is really important for you to understand. These are orally active. This is after ingestion, after going through the microbiome, into the blood of bees, activate and pass the cytochrome P450 pathway, reducing viruses by several orders of magnitude, and bees are the most second well-studied animal in the world. This is an animal clinical study. This is not an in vitro test. This is a real-world test with measurable results and helping the bees survive and reducing viruses. Now, this is extraordinarily exciting. Our team's like, are these results, are they really true? We have done this repeatedly over and over. We have one result that I'll mention. I'm not going to stand here and say that we've authenticated it yet. Another result that we got, we reduced the viruses more than 200 million to 1 with 1 treatment. Unfortunately, the number of beehives we had tested was small, so we were now going into 10,000 beehives that our company is sponsoring, that we're doing this pro bono for free. Now let's bring it back to bears. We all grew up with Winnie the Pooh. This is the bee mushroom theory. Bears scratch trees. Fungi grow in the trees get soft, cavity dwellers come in, bees come in, honey is being produced, bears go after the honey. Are bears scratching the trees knowing that 3 years later they come back to find bees and honey? Maybe so. Think of it. If you're a bear, wouldn't you want to find the honey? Come back? Life is interconnected. Now, of course, I had to file patents on this. That's what I do because I'm outside of academia and I've learned, unfortunately, scientists have egos. Those of you who published in peer-reviewed articles, I'm sure that you didn't give credit or acknowledgement to one of your competitors you didn't like. With a patent office, they're totally objective. And so when I got the first patent on this, for 5 minutes, my ego went, wow, Stamets, cool. And then I frankly got horribly depressed. I go, really? I'm the first one? We grew up with a Winnie the Pooh? All of us? The patent office did massive search engines, every language, German, Japanese, Russian, Chinese, English. And there's no prior art, no mentioning anywhere in the scientific literature or popular literature that bees are attracted to mycelium because of immunological benefit. Moreover, they are attracted and they benefit for a reduction of viruses and helping their lifespan. Hiding in plain sight. We are Neanderthals with nuclear weapons. We're so attached to our friggin' devices. We're so bought into the pharmaceutical, drug machine that we have to find magic bullets with specific targets. Patents now issued in the United States, Canada, New Zealand, Eurasia, and Europe. I want to file the patents to create the vehicle financially to make it open sourced. It has to have a profitable path. And you ask me, well, why do you patent this? Okay, I can open source it. Monsanto the next day will greenwash and say that they're a part of this. I can control the chain of custody of the intellectual property to benefit the people who are like us, who are joined together to be ecological warriors, to be able to help the planet. Those are the people I want to help. I don't want to help Monsanto now. So, to credit my fellow researchers from the Washington State University team and our Myco team and our company, these are the people who have contributed substantially. This is an ecologically rational, economically sustainable, scalable, and delivery system, and we can use native species anywhere in the world. I don't have to use the strains from Washington State or Oregon or British Columbia. These polypore mushrooms grow virtually in every woodlands of the world. And the bees that co-evolved in those woodlands, why not use native species? We can set up laboratories that's scalable, that's teachable. I can teach anyone how to do this. So we partnered with Washington State University. I didn't get stung. The bees seem to like me. My partner Dusty and I have contributed over $150,000 in our own personal money to sponsor research at Washington State University. Many of you have participated in this. The funds that our company receives and the other people who are involved. We had the Give Back program, like John Lennon's Give Peace a Chance. Bessie came up with this, one of our employees. Give bees a chance, give back. It's a double entendre, you know, get it? Yeah. I think it's really clever. So we have now just got received a report from Washington State University. I have this document, it's publicly available. We have generated now, because of our efforts, where we tell people, support Washington University. I want everyone here to consider this. They're raising $20 million for a pollinator bee research facility in Pullman, Washington. And our efforts, and I have a report, we have raised more than $3 million. But it's not all good news. There's a problem. It's not legal. It's not legal because of what the U.S. Department of Agriculture has an approved feed list, the AFCO list. Mushroom mycelium is not on it, nor are mushrooms. It's illegal for us to sell this to help bees when worldwide food biosecurity is at stake. It's illegal to help the bees with these extracts when bees are the #1 bridge issue between liberals and conservatives. They've done these studies. If you go to Thanksgiving dinner, you don't want to talk about Trump and Hillary or Benghazi, you know, talk about bees. My mother's charismatic Christian community, they're all about food security. They're all about protecting bees. Hippie liberals, yeah, give the bees. Yeah, we're on board. So, mycofactor E, okay? But wait, there's more. Let's go back to p-coumaric acid. By now you know about p-coumaric acid, the cytochrome P450 pathway. The bees, when they're healthy, p-coumaric acid is in the honey. Where's the p-coumaric acid coming from, Stamets? I go to sleep, smoke a joint before I go to sleep. I have another waking dream. Oh my gosh. We have now 80 strains of Agarikon in our cultural library. When I tested the BioShield Biodefense program, we had 5, 3 were active, 2 were not. So not all the strains of Agarikon are the same. Now I have 80. So I thought to myself, we have 80 strains. We're gonna have a super producer in there. There's gonna be some strain in there that's really potent. That's the way genetics work, with extracellular metabolites, secondary metabolites, antiviral compounds. So I write NIH, National Institute of Health Virology, Dr. Chris Tsang, was the chief virologist in that department for more than 30 years. And he was one who kept on saying, we're going to do more work with Paul Stamets' extracts. And rubber stamped us through 2,392 assays. So I wrote Chris. I said, Chris, we have 80 strains of Agarikon. 3 of the 5 were active against viruses through the BioShield Biodefense Program. We'd like to submit all 80 of them for you to do testing. 17 minutes later, he writes back. I'm like, wow, that was fast. He said, Paul, we love working for you, but we don't have $2 billion anymore from the BioShield Biodefense Program that closed down in 2009. But we will test pure structures. Now that's scientific lingo for a molecule. You send us a molecule, and if our virologists decide that that molecule is, number one, never been tested before, unprecedented, no one has ever published on it before, if psychologically and pharmacokinetically it doesn't make sense to the virologist, can it get into the bloodstream? Beta-glucans cannot get into the bloodstream. Can these antiviral structures, molecules that you propose, can they get into the bloodstream? So it's not good news, bad news. Nice that Chris wrote back in 17 minutes. Paul, we want to do biogat fractionation for you. We will not, his words, bioprospect for you. We don't have the money, you know? So, I know. So I go back to sleep again. Smoke a joint. Have another waking dream. Think of p-coumaric acid. I know p-coumaric acid. It's important for the bees. We know it's important for the bees. P-coumaric acid. I'm not a chemist. So I'm gonna look up the literature on the delignification of wood. You dig into a rotted log, sometimes it smells good. It has a vanilla-like fragrance to it. That's why the wood smells so good. The forest smells so good so much well after a rain because of all the polyphenols and mycoflavonoids and the aroma molecules are coming from the mycelium, percolating on the ground. All that mycelium is respiring, and all these compounds are coming out. That's why the wood smells so good. You can dig into a rotted log, you can smell it as well. I go, well, I'm going to look at the delignification pathways of wood. So I said p-coumaric acid. And I started going down the p-coumaric acid derivatives, compounds that are being split from p-coumaric acid. And I go, okay. So I write Chris at NIH. I said, okay, I have 10 molecules, 10 structures. And I want you to test these structures. So they juried them. They said, no prior art, no one's ever tested these structures before. Stamets, go ahead and send in your 10 structures. So I did, against a panel of viruses. This is the direct report from NIH against the human papillomavirus. And these are NIH's red lettering, highly active. 1, 2, 3, 4, 5. 5 of the molecules that I submitted were highly active against the human papillomavirus. 75% of women in this audience have it, 50% of men. It causes a sleeping time bomb, causing cervical cancer. It can metastasize. It can cause esophageal cancer. The preeminent cidofovir, which is the drug control, only has a sleep activity index of 12. That's piss poor, folks. There is no good antiviral against the human papillomavirus. It is a sinister sleeping time bomb that will cause enormous devastation to the younger population in particular as we progress. It is rampant. So it turns out the compounds I submitted were all polyphenols that were related to p-coumaric acid. Rather than spending hundreds of thousands of dollars in 5 years doing biogat fractionation, I used the best of all scientific methods. I guessed. And here's our results. The selectivity index numbers are huge, over 100. And when I found out that vanillic acid, vanillin becomes vanillic acid, is active against herpes zoster, or the varicella zoster virus, that causes shingles. Acyclovir is a multi-billion-dollar drug. You've seen the advertisements on TV. And vanillic acid is more potent than acyclovir in reducing herpes zoster, which is basically a re-emergence of chickenpox. And we found one against the norovirus. We found one against polio, directly from the NIH. I thought of that. I'm waiting. And it got approved. I'm not a chemist. So, in scanning all the literature, no one tested vanilla as an antiviral. These are common flavor molecules, polyphenols, way apart from the beta-glucans, not soluble in water. And so now, using quantitative PCR, those of you who are PCR people can respect that, they actually count the viral particles. And because there's such a long history of use, vanilla, over 200 years of study, incredibly safe. We are now fast-tracked to be able to propose a clinical study where the clinical drug will smell like vanilla. Oh, this is the weirdest part of the story. P-coumaric acid is not active. What led me to this discovery was P-coumaric acid is not active at all. WTF, folks? Mycofactor F. So I want to conclude that this is the mycofactorial equation for a paradigm shift, a revolutionary solution for disease prevention and protecting biodiversity. We need, and looking at psilocybin, neurogenesis, antivirals, reducing pox, bees attracted to mycelium, bear scratches reduce polypore mushrooms, polypore mushroom extracts reduce B viruses, molecules related to p-coumaric acid reduce HPV viruses, and G, which I've not talked about, was that we can limit the spread of diseases, viral diseases, by insects to plants. I think I've found something fundamental to the foundation of nature. For millions of people, years, we were forest people in contact with nature, dependent upon the forest lands in which we lived. 10 to 14,000 years ago, we invented agriculture. What do? We cut down the trees. When we cut down the trees, we began to dismantle the menu that the mycelium needed. The fact that these same extracts produce viruses that afflict humans, birds, pigs, and bees speaks to a fundamental truth. The mycelial networks in nature affect and influence and support the immunological health of the plant and animal residents that reside within. We need to celebrate decomposition. We need to let it rot. Give up the concept of having an Elizabethan, pure, manicured yard. Mycelium in nature likes fractal diversity. Fractal faces. Mycelium is an edge runner organism. It's the interface between life and death. They're running on the edges of ecosystems as they intersect each other. You need to have wood rotting on your property. Give a disheveled, highly fractalized environment, gives lots of micro niches for all the biodiverse members in that community. A monocultural landscape does not. Mycodiversity is biodiversity. Humans, trees, bears, mushrooms, the birds, the bees, all terrestrial organisms have evolved to be interconnected with the mycelial web of life within Earth's natural internet. This is the foundation of our life. We will all exist together in the micromolecular matrix of being. It's time for us to create and engage in the paradigm shift into the future together. Thank you very much. Bless you all. You survived an immersion talk, a Stamets upon. What part of this talk should I have left off? It's just impossible to explain this story. But when you string all the mycofactors together, it makes sense. This is so important for future generations. We've found the keys to unlock doors of knowledge that others can walk through. It's not what you make in this lifetime, it's what you leave. It's how you're remembered, and that the generations that follow. Biggest reward in life that I can imagine is saving smiles on babies, their parents and the love that they give them, and the child expressing their love. I want to see more happy faces into the future. So bless all of you. Thank you for supporting us. I appreciate it.